your activity. You can start now.
Yes, ma'am. Is my screen visible, ma'am?
Yes.
Okay. So, good afternoon, my friends and teacher. Today I'm going to present the ANSYS simulation, the ANSYS software and the materials testing with it. So, I'm Maithili Belkawade from SE Electrical Engineering from AISSMS COE. Under the guidance of Professor and Dr. Mrs. Mangal Dhend ma'am, I've done this. So, let's begin. So first of all, we'll understand about the software, ANSYS software. ANSYS is a basically CAE software, that is computer aided engineering software, which we engineers use for analysis purpose and task related to it. So ANSYS is basically user-friendly software, bit advanced, which is used in testing of components in different industries in order to test material used in the component before the manufacturing stage. So it saves a lot of efforts and also money, as one can test the object virtually before actually making it. So in this software we can use the CAD design, that is computer aided design, and its simulation can be done. So we can analyze the strength, toughness, elasticity, temperature distribution, electromagnetism, fluid flow, and many other attributes. So today I'm going to show you the ANSYS simulation on the motor plate we use. Generally in vehicles where we use the motors, the force comes on the chassis members if we mount it directly on the chassis, but we don't do it as motor had some torque and there are lot of vibrations because of it. So we use the motor plate to mount the motor on it. So I've taken the motor plate CAD. I've made it in the SolidWorks software. The CAD design we can make in any CAD modeling softwares like AutoCAD, Creo, CATIA, or SolidWorks. I've made it in SolidWorks. So this is the data about my component I'm going to use. I'm using the material mild steel in it, as we are going to laser cut that component. This is the picture of the CAD. The one is in between is the motor plate, and in the other two pictures I have showed how it is placed, the motor is placed, and the side faces of that motor plate are welded on the chassis so that forces are distributed. So in ANSYS, there we can put the material and the material properties. So as I'm using the mild steel, I have put these properties in it, and force, that is the weight of the motor, is acting on that plate. So I've taken the force acting on the plate as 45.0908 Newton. So we'll see the simulation.
Hello friends. So here we will see how to do the static structural analysis of component in the ANSYS software. So we'll open the workbench. This is the 2018 version of ANSYS. It might take some time to get started. These softwares need the high RAM, good graphics to run. Like on 8 GB RAM PC you can run it. Basically, ANSYS software is used in many industries for doing the analysis of the components before manufacturing it. So it saves much of the cost, and we can test our component virtually before actually going for its manufacturing processes. So here you can see the toolbox. There are many types of analysis we can do on the components, like modal analysis, electric analysis, harmonic. So we'll choose the static structural analysis I've already chosen. So we'll go to the engineering data first, where we have to put our material and the details about the material. So as you can see here is a toolbox where we can put the materials and properties we want to put there. So here you can see the structural steel. It is by default, but I want the mild steel. As I'm going to do the analysis on the motor plate, I'm using the mild steel material for it. And as I'm going to do the laser cutting of it, I need to use it. So I'll put the mild steel here as it is not present. Actually, here is a library of it where we can use any of the materials, but the one I want is not present there. So I'll put the I'll put properties I want to. So I choose the density, isotropic elasticity, alternating stress and mean stress. So that's about it. So I'll put the values. I have got these values from internet. So our density of mild steel 7100 meter kg per meter cube. Then Young's modulus I want in megapascal. I choose it. So value of it is 2E plus 0.5 megapascal. It will update the values. Yeah. In the Poisson's ratio I want 0.27. So accordingly the values will get changed. Yeah. So here I want to do the fatigue analysis. So I'll put some cycles and values over here as I want. So I'll put the cycles as 10,000, 10,000, 20,000, 50,000, 1 lakh, 5 lakh, and 10 lakh. Here I'll put alternating space in Pascal, megapascal I wanted. So I'll choose the unit. I'll put it as 300. I've chosen these values for the analysis as I've learned from the YouTube videos I've referred for the learning of this software. You might change it. So I've put the values. Here is a graph of the values I've put. So I want it as in this way. Alright, so we have done with our material assigning. So we'll go to our project again. Now we have to import the geometry. As I've mentioned in my PPT, we can make the CAD model, computer aided design model, in any CAD software like SolidWorks, AutoCAD, or CATIA, etc. There are many softwares. So if you want to import, here is the new design modeler geometry. We'll go to there. It takes some time to load. As you can see, it is written in the bottom that starting design modeler. The process is being carried. So in this section, we'll go to the file. You can see here many options, like we can draw here a geometry too. So I'll go to the import external geometry file as I have made it in the SolidWorks. I'll select the file I want. I'll open. So I need to generate. So I'll click on generate. So as you can see, here is the geometry generated. Is a part one body file. So now we'll go to again our workbench. So I'll double click on model to start our project. Here you can see the starting mechanical, that is the command is being processed. So this is our design. First we'll go to the geometry. click on our model. Here in material assignment, here it is showing structural steel by default, but we want to use mild steel, so I'll select it as I have put the values of it in the project already. Then we'll go to the mesh tab. Here there are many options how I want it. I want it as fine, so I'll select it. So it will be the fine meshing. So I'll right click on it and we'll generate the mesh. Okay, so meshing has done. So in structural, static structural, we'll insert some fixed support. As this plate is going to be welded on the chassis, I'll select the faces to be welded, so there will be the fixed support. Simply apply the faces. Yeah, it's selected. Then also I want to add the force. As motor is going to be mounted on this, the force will be applied on this upper face. So I'll select the face on which the force is going to be applied. I'll say apply. Now, how much force it is? So the weight of motor is 4.6 kg. So the total force will be 45.08 Newton on the face. Now here direction we can change, like it is showing outwards, but it should be inwards. So we'll change it. It is choose it. Yeah, now you can see the direction has changed. It is putting the force uniformly on the plate. Yeah. Now in the solution, in insert, we'll add the strain, equivalent strain, as I want to calculate the strain which will come on the plate after some cycles, and I'll ask for total deformation. Okay, so I've put the values I want, and now we'll run the solution. It might take some time. You can see here different options, like different types of analysis can be done on this. Like I have selected the strain. There is some error, but I'll check. Actually, first I did a mistake in this mesh option in sizing. I chose the fine mesh at here, but I had to choose it in the relevant center. So now I have run the solution, and here it is. Solution has come. So we'll check the equivalent elastic strain. So this is wait. Check it in this way so that everyone can see it. Okay, we'll choose this scale. We can choose it. We'll choose the 2 scale. So we can see here is the color table. So from this we can see at what place of the plate how much of the stress is coming. So the red is obviously, as red is for dangerous, the red is the more stress and the blue is less. So we can run it. So in this way the forces are going to be applied. You can see. So it depends on the type of ANSYS we are doing. So it is about it. We can see the total deformation. It is after some cycles. So after applying the force repeatedly on the plate, after some cycles, the total deformation will be done. Here the between you can see the red color. Also we can add the fatigue tool. And we can insert the life. We can run it and get the results of it too. So as you can see, you can do the fatigue analysis too. Here you in the probe option, if you select the probe option, minimum and maximum, you can see the maximum stress has been applied at what place and minimum stress is applied on what place. Also, whenever you can, you will put your mouse on the surface, you can see the value of force applied at that place. So in this way, you can do the analysis. So we can do optimization of our design or can make changes in the design of the component accordingly. So this is about it. It is easy to learn and user-friendly software. Thank you.
So this is the result we got. Like using this, we can calculate the points of our component where more stress is getting or we are getting less stress. So accordingly, we can make changes in our design. So this software is been used in many industries like automobile, civil industries, in many like manufacturing industries. So
Very good, Maithili. Nice presentation. Excellent. You are just demonstrated using software or it's pre-recorded? Maithili?
ma'am, I recorded it before.
Okay. Just you send me this recording and others. What about you?
Yes, ma'am. I have recorded it before.
Okay. Now you both of you just give me your video files, mail me, and call me after this session. Now I'm just want to stop here, and in tomorrow's practical, we don't have practical today, timetable is changed. In tomorrow's practical, I will take batch A and B, so be ready, remaining students from A batch, and also B batch, be ready in tomorrow's practical. And even if now again timetable will change today and it will be compiled with means your batch A, another practicals, I will change that. Okay, so just